Okay, so this is for Nursing 110, workshop number 2 for spring 2026, and we're just going to get right into it. So, as I mentioned before in the last review, you have to know your conversions. So, they're not going to be given to you. You need to know how to go from milligrams to grams. Okay, so when we're doing this, I'll remind you like 1 gram is 1,000 milligrams as we're going through. But like you need to know that it's not going to be given to you. You're not going to get a table on the side. You have to know that 1 gram is 1,000 milligrams. Okay. So when I'm making a conversion, I want to take there's a couple ways you can do this. The easy way is just if you know where this is going, just move the decimal over 1, 2, 3, and then you just put your answer as 1.5 grams. Okay, it could be as simple as that. If you need a little extra practice and you want to get a little bit better at dimensional analysis, this is a good one to practice with. The question I always ask is when we're making a conversion, what do we want to get rid of and what are we trying to convert to? So before you write any numbers, write the units. And then 1 gram and 1,000 milligrams. That's why I'm saying like you need to know that. So if you ever get stuck or you ever convert this the wrong way or you move your decimal to the right when you should move it to the left, write it out. So at least you know if you know that you're dividing by 1,000, that should be a clue that your number is going to get smaller. And if you're multiplying by 1,000, your number is going to get bigger. Okay. Let's look at this one. So you need to know that 1 milligram equals 1,000 micrograms. Now, sometimes you'll see that microgram written out like this. Sorry, it's supposed to be a G, not a Q. So it'll look like a letter U or like a weird looking M, G. Just know that it means the same thing. So if you see those and you get stuck on that, just know. And I'll show you because that's actually on some of your labels. So you'll see it. So again, I'm going to do the same thing. I could just move my decimal 3 places, and then I would put an answer of 0.25. Or I take my 250 micrograms, and I convert it micrograms to milligrams, 1 milligram, 1,000 micrograms. And again, I get 0.25. So the reason for giving you a variety of ways is just to remind you that there's not just one correct, like this is the way you have to do it. There are a couple different ways, but what you want to pay attention to is if you're getting it consistently right. Like I said, commonly missed first semester, usually it's first semester, this usually fix this issue going into second semester, is you're rushing through the test and then you're converting the wrong direction. So you turn this into 250,000 milligrams and you turn this into 1.5 million grams. Okay. Don't do that. Make sure, take your time and like just write it out. Okay. And we'll look at later on, we'll look at other examples, but this is typically what you're going to see is how we convert that. But we could go the other direction too. We can go from milligrams to micrograms. We'll worry about that on another day. So I had a question about this one last time. So when we're doing this, even if you get an answer that's like 0.125, you don't round these metric to metric conversions. When I say metric means grams, liters, cubic centimeters, even though you won't really use that too much, meters, kilometers, kilograms. Those are all considered metric, right? The metric system. If you're staying in the metric system and you're just converting metric to metric, do not round your answer, okay? If, however, you're going from like here, pounds to kilograms, pounds is considered a household unit, kilograms is a metric unit. So we're doing different units. If you're going into different units and you get like a long decimal answer, round to the nearest tenth. Okay. Later on, when you're in actual clinical practice and you're working with patients, when you convert pounds to kilograms, you'll probably just go to the nearest whole kilogram. But from what I understand, and from what others have told me, and sometimes they even will say it on ATI, round your answer to the nearest tenth. So that's what I'm going to tell you to do. So you need to know that 1 kilogram is equal to 2.2 pounds. If I'm doing a conversion, I'm going to write 165 pounds, create a conversion. I'm going from pounds to kilograms. And again, 1 kilogram is 2.2 pounds. So it reminds you to divide. Okay. If anything else, if you're sitting there going like, well, what am I supposed to focus on? Like how will I know the multiplier divide? I'm telling you, if you write it out, you'll get used to it and it'll start to just kind of make sense because you've written it out so many times that you won't get confused on when you should multiply or when you should divide because you'll know how to set it up. And then if you do get confused, you get a piece of paper out and you write it out and then you go, oh, okay. I will say this, another thing that students tend to goof up on this test is you think you know it, you write out an answer, you move on to the next one, and then you did know it, but you set it up wrong. So make sure you're writing something down so that way you can double check your work before you hit that final submission. So we're going to do the same thing here. So from here on out, I'm just going to divide. Just going to divide by 2.2. So I'm just going to say divide by 2.2. Oh, I didn't even answer this one. Sorry. Let me pull up my calculator here. All right, so 165 divided by 2.2. When I do that, I get an even 75. Okay, so we don't have to do any rounding. We just put 75. For 117 divided by 2.2, now I get this long, crazy number, right? 53.181818. They don't want you to write all those numbers. And you might be tempted because of other classes to like round to like the two numbers here. They don't want you to do that. They want you to round it to the nearest tenth. Okay. When you have a number greater than 1, and that's mainly for volume type questions like milliliters, round to the nearest tenth. Okay. So how do I do that? I look at that 8. If that number where the 8 is in the hundredths place, if it's 5 or greater, so 5, 6, 7, 8, 9, you're going to round the number in the tenths place up. If that number is 4, 3, 2, 1, or 0, then you don't round. You just leave it alone. So if this was 53.14, you would just leave it as 53.1. But because it's 53.18, we are going to round our final answer to 53.2. Because I think someone that's here, I think it was Wilford, that had asked about the rounding, and that's the rounding rule that you need to know when we're going from the household units to the metric system. Okay, so notice I didn't say anything about rounding up here. We didn't need to round this one because it was a whole number, but this one I had to round. Okay. Same thing with this. Again, we're just going to divide by 2.2. 182 divided by 2.2. So notice that we get, notice that we have 82.727272. I see your comment, Nelly. So hopefully I'm going to answer your comment now. So we have 82.72. We look at the 2, right? So if that number is 2 or like 43210, then we leave the 7 alone. We do not round it up. Okay. So we just put our final answer as the 82.7 kilograms. Go ahead, Nelly. What's your question? Okay. So in your example, you asked, okay, so what do you think you should do? Round that number you put in there. Yeah, so tell me for the 3.555, what would you round that to? So you're rounding it to the hundredths place when you round it to 0.56. So if we want it in the tenths is the number. So, yeah, so you've rounded it to the hundredths place. We want to round it to the tenths. So the tenths is the 5. So I'm going to write it out. So I'm going to use your example. So 3.555. So this place right here is the tenths. This place right here is the hundredths. And this place right here is the thousandths. So if we say round to the nearest tenth, we're asking what we're going to do with that number. So we have to look at the hundredths place to determine what to do with that number. So if it says round to the nearest tenth, if it's 5 or greater, 5, 6, 7, 8, 9, 10, 5, 6, 7, 8, or 9, then we're going to round the 5 up to 6. So we'd round that to 3.6. So again, the tenths place is the first place after the decimal. I know it gets a little confusing because this is the ones place. And then you have the tens, hundreds, thousands. But remember, if I take 3 divided by 10, it becomes 0.3. That's where the term comes. So there is no ones place because anything divided by 1 is itself, right? So just in case you were like wondering about that. So not necessarily. So usually, ideally, you're shooting for 2 numbers, but like sometimes you're going to get an answer that's just like 6. That's your answer. You don't have to put 6.0 or anything like that. But if you have a number like here, right? We have 3 numbers here, the 53.2. In the example you gave me, yeah, we would just have the 2 numbers, the 3 and the 6. So how would you do that second rounding question, the second number set you gave me? You said 3.353. So what would you round 3.353 to? So you said, let me just double check. You said 3 point, let me just double check that. 3.353. So if I have 3.353, we would again look at the tenths place is 3. So we only have 2 options. We're either going to round it up to 4 or leave it at 3. So we would round that to 3.4. I think you were talking, I think you wrote 3.6 as for the previous one that you gave me. You gave me two examples. Okay. Milliliters to ounces. You need to know that 1 ounce is equal to 30 milliliters. Because like I said, they're not going to give it to you. Now, these ounces they're talking about are fluid ounces because you've probably heard of like pounds and ounces for weight. We're not really dealing with weight-based ounces, so you won't have to worry about that, thankfully. So sometimes you'll see that written as OZ for ounce. Sometimes you'll see it written as FLOZ. So like, which indicates fluid ounce. FLUID, in case that sounded phlegmy. So sometimes it'll be a nice, even, like, conversion, but sometimes it's like this. Now, let me ask you something before I answer anything. This right here is the metric system. This right here is the household system. Would I round my answer if I get like a decimal answer in this question? Just type in the chat if you can, yes or no. Yeah, good. Because we're going into, I don't know what that is. I think your keyboard's in a different language, probably your language, so or your native tongue. So, anyways, yes, everyone's saying yes, which is good. So if we need to, just know that it's okay. For like this right here, question 7, I'm going from milliliters to liters. So I'm going from metric to metric. Would I round for question 7? Yes or no? Good. Yeah. You got it. If I could train you when to, or at least to pay attention, even if you're not 100% certain of when to round and when not to round, you're doing good. So yeah, you would not round, and we'll come to this and I'll show you when we get our answer in just a little bit. But anyways, let's go back to this. So how do I set this up? So again, I'm going to show you the dimensional analysis way because this is a good strategy to know in case you ever get stuck, especially for these conversions. Okay. I'm trying to go from milliliters to ounces, and I know that 1 ounce is 30 milliliters. So I'm going to take 200 divided by 30, and I'm going to get that right there. So in the chat, what would my answer be for this question? What number am I going to write as my final answer when I have a number like 6.6 repeating? There it is. Yeah, good job, Abigail. So hopefully you're starting to pick up on the rounding, right? So 6.6, then I look at the next number 6. If it's 5 or greater, that tells me to round the tenths place up. If it's 4 or fewer, we don't round. Okay, so good. Yeah, good job, Wilford. Yeah, so 6.7 is our answer for question 6. For this question, 1 liter equals 1,000 milliliters. So again, you could just, if you feel confident with this, you can just move your decimal point over. You get 0.35 and you're done. Or take your 350 milliliters, create a conversion. We don't want milliliters. We do want liters. 1 liter, 1,000 milliliters. Again, if you ever get stuck, as long as you have this memorized, you just put the number with the letter. Okay? And then you'll know that you set this up properly because they'll cancel out. They can only cancel out if there's one in the numerator on top or one on bottom. Some students get stuck on this. If it makes you feel better, you could put that over 1. It's not necessary, but they're supposed to be at the same level. So numerator, denominator, numerator, denominator. All right, let's look at question 8. Here's another one that you need to know. You need to know that 1 teaspoon is equal to 5 ml. I have 30 ml. I want to know how many teaspoons that is. 1 teaspoon is 5 ml. So we're just going to take 30 divided by 5, and then I'm going to get an answer of 6. How many ounces is 30 ml? Good job. Yeah, so that's 1 ounce. How many tablespoons is 30 ml? Just seeing if you know this. Good job. Yeah, so 2 tablespoons is the same thing as 1 ounce, which is the same thing as 6 teaspoons. And you might think that you learned this primarily in nursing. I've actually learned a lot of my teaspoon, tablespoon, and ounces conversions from cooking. So like when you bake and it tells you like you need a teaspoon for a single recipe, but if you want to double or triple it, and if you're tripling it and it's 1 teaspoon, then you put a tablespoon in for a triple recipe. Anyways, just trying to bring it to you. So if you enjoy cooking, you can integrate some of that, at least into the teaspoon, tablespoon stuff. All right, what about tablespoons to milliliters? So 1 tablespoon is equal to 15 ml. So it says 2.5 tablespoons. How many mLs? So this is the one where we can actually write, we're going to write something a little bit different than what we've been writing as far as our conversions. Because typically we've been, every single time, every example I've given you thus far has been dividing. We're actually going to multiply this time. So I'm going to take 2.5 times 15. And I'm going to get 37.5 ml. So that's what it goes up to. It just goes to 37.5. So you don't need to worry about you don't need to worry about rounding because it's already at the tens place. There's nothing to round. Okay. All right, let's look at the next page. All right. So this one is going to give us a little extra information. So I'll actually, let me grab another sheet of paper here because I realized that the back of this, I should have did this on individual sheets. So this question is asking us to calculate a replacement volume after a patient they're on a PEG tube, they're voiding out, and we want to know how much water to give them in replacement. Okay. So a couple of important things. So what it says, for every 125 milliliters of urine output, replace with 40 milliliters of water. So this is kind of like I always call this your expected out. This is your replacement. And then it says if the urine output for the last 4 hours is 500, so that 500, this is your actual output. So what the patient actually voided was 500 milliliters. Now, this is where I kind of deviate a little bit from my traditional teaching of dimensional analysis, because this type of question actually works best if you do either ratio proportion, or because this question is so unique, you can have a formula to help you out with this question. So let's look at from the standpoint of a like a ratio proportion. What I mean by that is, let's say I have 40 mLs as my replacement volume, and that's related to the 125 milliliters, which is the output. When I could set that equal to the 500 milliliters, which was an output, and then we're looking for that. Okay. Now, some of you might be getting flashbacks and haunted by the memories of algebra. You don't have to do that. One of the things you could do is just find out, like, what is the multiple to go from 125 to 500. 125 to 500 is just times 4. So whatever I do here, I also do here. The formula that seems to work out for questions like this, you take your actual output over your expected out, and then multiply that by your replacement volume. And that'll also give you your answer, which is, in this scenario, that would be 500 over 125 times 40. And then you get the same answer, 160. I think a lot of students do better like seeing this, because you can kind of see the conversion. And if you're wondering, like, how did I figure out times 4? Well, the simple way of doing that is take the bigger number. So take the 500 divided by 125, and that's where that number 4 comes from. And then you could confirm it, 125 times 4, and then you can see we get 500. So you have a couple of ways to kind of identify or to get to that answer, okay? So I think we're going to do the same thing for question 12. But this time, what happened? They just changed the numbers. So the question's written exactly the same for every 100 milliliters, replaced with now 30. And if the output is 400, then what is it going to be? So the multiple is the same, right? So 100 to 400 is times 4. So 4 times 30, that would just be 120 ml. This was 160 ml. That's supposed to be a 2. Sorry, everybody. Okay. So the trick is just practicing what these are. The other thing is I'll mention is, if the replacement for a loss of 100 is 30 and the actual loss is 400, something that should trigger your mind is like, I'm going to give them more than 30, right? So that's like how you want to make that connection. It's just like, if you lose more, you're going to replace with more. If it was 100 and it replaced with 30 and they only lost 100, then your answer would just be 30. So just find the difference between these two, the 100 and the 400, and then multiply that by your replacement volume. And that should give you your answer every time. All right, so this one I have to pull up, and I'm going to share my screen. So the question says your patient receives 500 milligrams by mouth, BID, and then asks how many capsules will they receive per dose. Now that's important to take note. Usually you're looking for per dose, okay? If they wanted to know how many per day, they would say how many capsules per day, okay? You might get asked that question, just letting you know. So it says your patient receives 500 milligrams. PO means per oral or by mouth. BID means 2 times per day. And I talked about how you can learn the different ways to learn the shorthand. There's that sheet in the on Blackboard that you can reference, or just pick up as you'll hear me explain what each of these things mean. When we're looking at the label, we want to pay attention to a couple of things. We want to pay attention to what is the strength of the medication. So it's 250 milligrams. And we want to pay attention to how it's administered, capsules. The 100 just tells you the total number of capsules in the bottle, and you're not giving them 100 per 250 milligrams, okay? If you think about it, like if you've ever taken Tylenol, you didn't take the whole bottle. You took 1 or 2, right? 2 every 8 hours or whatever it tells you to do, okay? Here it tells you specifically 1 capsule every 6 hours. That's the recommended adult dose. This is actually going in a different direction as far as that's concerned. It won't be a problem. So how do I solve for this? This is where the order over available works just fine. You could do quantity, or you could actually do dimensional analysis with this, but I'll do because it's typically what most students do. If you don't just automatically go in your head that it's 2, I'll just do it as order over available. So let me show you how I'd write that out. So for this one, when it says, hold on a second, let me just fold this down. When it says your patient receives 500 milligrams by mouth BID, and we know, so our order is the 500 milligrams, and then our available is the 250 milligrams per capsule. So to solve this, I'm just going to take my 500 milligrams, my order, over my available 250 milligrams, times my quantity, which is the 1 capsule. 500 over 250 gives me an answer of 2 capsules. It's important that you remember to include your quantity, because especially when we get to our liquid medications, sometimes it's not 1, sometimes it's 5, sometimes it's 15. So we want to make sure we're paying attention to the numbers. Such as question 14. Now, question 14 actually gives us the order and the available, and we just need to mark the cup. So I'll solve 14, and then we'll go into the marking on there. And I know I already did this with you last time, but it's good to see it again. So what's the order? The order is 40 MEQ. If you're looking at that going like, what in the world is MEQ? MEQ just stands for milliequivalent, and that's just the way that potassium chloride elixir is ordered. So that's just how it is. So like insulin is units, and most everything else is milligrams or micrograms. When you see PO, now you should start to be figuring out that's by mouth. QID actually means 4 times per day. Or every 6 hours, right? Because there's 4 6-hour intervals in a 24-hour period. So sometimes you might see QID written out as Q6H, which stands for every 6 hours. I'm just trying to show you just a couple of varieties just in case, because not every question that you're seeing is going to be verbatim when you take your actual test. The available. The available says 20 milliequivalents. And then it says per, so I'm just going to write a slash, 15 ml. So you need to know that your available is that entire thing. It's 20 milliequivalents per 15 ml. The 15 ml is your quantity. Then it says how many ml will you administer for 1 dose. So you're going to take your 40 milliequivalents over your available 20 milliequivalents times your quantity, which is 15. Before you even solve anything, you at least know you're in the right final unit that you're looking for. 40 over 20 is 2 times 15 is 30 ml. Then going back to here, you would just drop. Now I'm in the I've like submitted this already, so you would just drop your pointer either on the line or on the number. I would recommend on the line, but when they do the key for where you can like kind of place your marker and get this correct, kind of looks like this. So it's a pretty big window. So you could put it here, 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 here. As long as it's in the box, it's marked as correct. So I'm just letting you know where that is. But I would suggest marking it in the center on the line as best you can. Okay. And then remember, there's a reset configuration if you mess up. Okay, so let's go to the next question. Oh, this is another, has a label. So this is the dilantin question. So let me go back to our share. All right, so for this one, you can see when we're looking at this label, we have a couple of things. So first of all, this is our order, 250 milligrams. It just says straight up by mouth. Pay attention. This is also a commonly missed question because it's asking you how many teaspoons will you give, and then it repeats how many teaspoons will you give, or teaspoons, for this. So when we're looking at a label like this, it's helpful to know the strength of the medication or what's available is usually highlighted for you. So it's usually nice and big and bold and lets you know. You don't need to worry about how much the whole bottle is. You don't need to worry about the 125 by itself. You need to pay attention to the whole thing. You're looking for, if it's a liquid solution, which dilantin is, and the way you would know that is it says oral suspension. So if you see oral suspension, that's your clue that it consists of milliliters, okay? That you're going to drink it, or the patient's going to drink it. So it's 125 milligrams per 5 ml, okay? So we want to use that's our available. So let's work it out. Hold my sheet again. So again, my order is 250 milligrams. My available is the 125 milligrams per 5 ml. Sorry, I was trying to slide this up a little bit. So when I'm solving this, if I want to just solve for the mLs, we could do that first. And then I'll show you a little cheat code. Times my quantity. So order, available, quantity. And then I'm going to get 10 ml. That's the answer that most students who end up getting this question wrong write. It is correct, but it asks you to give the answer in teaspoons. So I need to convert 10 ml to teaspoons. And you recall that 1 teaspoon is 5 ml. So my answer would be 2 teaspoons. Now I'm going to show you a little shortcut. Since we know that 5 ml is equal to 1 teaspoon, the other way I could have solved this problem, since I knew I was looking for teaspoons to begin with, is I could actually just substitute my 5 ml for 1 teaspoon. And when I do that, I get right to my answer. So you could substitute this because they're equivalents. Okay. I can't just put any number there, or I can't just say, oh, okay, 5 mLs, that's the same thing as 2 turnips. No, you have to have a conversion for it. Okay. So if that were 15 ml, you could say it's the same thing as 1 tablespoon. If it was 30 ml, you could say it's the same thing as 1 ounce. I'm telling you that just in case, if you get asked a question similar like that and then you get stuck, you have some flexibility with that. But the main thing is, and what they're testing you on here is read the question. Make sure you're answering the question that they're asking you. All right. The next question, number 16. Oh, yeah, I guess I can bring that down. Sorry for all the movement here. So number 16 says, your patient has V-Cillin K suspension, 150 milligrams orally. It says GID. That's not a thing. That's supposed to be a QID, which means 4 times per day. Okay. But that only matters if they ask you how much to give per day. But since they're asking for dose, and like I said, typically the question is asking how much per dose. So my order is the 150 milligrams. Okay. I need to go back to the Blackboard to share what the available is. Now this available is kind of crazy. Okay. There's actually quite a few things on here that can get really confusing real quick. And what I find, especially students so if you have somebody who's like, I got this, I don't need to go see and meet with that Dr. Rad guy. He sounds annoying. I don't think it's going to be helpful. At least tell them about this label, because this is a label that trips up even the best students as far as like you have a good grasp of the math. This comes down to being able to read the label. Okay. I take for granted that I can read these labels because I think I told you this last week. I used to be a pharmacy technician. And so I saw these labels every, all my hourly shifts that I was working, and I got used to seeing it. So when I look at it, I'm not confused by what I'm seeing. I know how to like narrow my focus down to what I'm looking for. I don't expect you to do that as a nursing student where you may have never seen these labels as they are. These are the labels you see in the pharmacy. These aren't the labels that you necessarily see in the pill bottles that you get from the pharmacy that they give to you as a patient. These are the way you're going to see these in clinical when you're doing your clinical rounds. And so that's why it's important to know how to look at these. And so a helpful tip is look at different labels, like do a search, do a Google search or whatever search you want to do, and look for drug or medication labels, just so you have a little bit more confidence about the different types of labels and what they look like. So why am I harping about this one in general? So a couple of things. When we look at the strength, it's actually giving us extra information that sometimes you don't know what to do with. Because you might be thinking, because of having had more advanced math, okay, am I supposed to multiply 125 milligrams by 200,000 units? No. When they put something in parentheses, that's just telling you it's an equivalent. So for this particular medication, what they're telling you is that 125 milligrams, I'm going to try and write this out, 125 milligrams is equal to the 200,000 units. Sorry again about my terrible handwriting. This is with the mouse. I'm just going to write you. So they're equivalents, okay? Why is that important? So let's say instead of 150 milligrams, this said the order was for 275,000 units. Now you don't need to worry about doing any kind of converting because I can use the units with a units order. But because my order is in milligrams, I'm just going to focus on my milligrams. I'm going to ignore that. And then it's 125 milligrams per 5 ml. So like I said, this is one of those questions where students will get like they'll miss just because they're not expecting to see it. So just pay attention to it and know to ignore the 200,000 units. That's just telling you it's an equivalent dosage. Okay. So I'm going to write my available as the 125 milligrams per 5 ml. And I'm going to show you what I wrote here in just a second. Turn that back on. Stop the share. Okay. So doing the order over available, my order is 150 milligrams. My available is 125 milligrams. My quantity is 5 ml. So I'm going to plug that into my calculator. I'm going to take 150 times 5. I get 750. And I'm going to divide by 125 for an answer of 6. So all that excitement for just 6 lousy milliliters. So when we see that this is like an oral-based medication, that the patient's supposed to be taking this orally 4 times a day, and it says it's only 6 milliliters. 6 milliliters is like a teaspoon. So my guess is that this order is probably not appropriate for an actual like adult patient unless it's supposed to be that like kind of small. Usually when you think about something you're consuming, then it might be more like a tablespoon at least of the medication, but it could be in teaspoons. Okay. So don't get hung up on the specifics, like what it should be. Just make sure you can do the math and solve the questions as they are. All right, the next question, and this will probably be the last one I'll do today. This is actually where we're going to see nystatin. So this is actually an oral swish and swallow. So this is for somebody with thrush, right? So this is an antifungal medication. So we have here our 150,000 units. So that's our order. So anytime I was writing O, so sometimes it's helpful just to kind of like key and mark up, even if you don't print off the actual test, just while you're writing notes, indicate what's the order, what's the available. Okay. QID, remember that just means 4 times a day. Could also mean every 6 hours. So I showed you that little q, 6, little h. It could also be written capitalized. This could also be written capitalized as QID. And sometimes they don't even include the decimal. How many mLs will you give for 1 dose? So we got to pull up our label. All right. So we can see our nystatin label. It tells me a whole bunch of things, but the thing I'm paying attention to is what's in that highlighted region of the medication. That's where it's going to tell me the units per ml. The units per ml is what you're paying attention to. You don't need to worry about what it says on the side label. You don't need to worry about the total amount that's in here. You just need to know what that is. Okay. Cherry mint flavored sounds like it might be okay, but I have a feeling that they put the mint because the cherry probably doesn't taste good. Anyways, so it's 100,000 units per ml. So I'm going to go back to my paper here. So my available is the 100,000 units per ml. So when I'm setting up this problem, I'm going to take my order over my available times my quantity. And I'm going to get an answer of 1.5 ml. All right. So I still have a few more that I'm going to work through. If you have been practicing, please keep practicing. I promise it should get boring. And that's where you know you got it down. If you're finding that you're making mistakes, let's say like you do it 3 times and you're getting it right 2 out of 3 times, pay attention to what you're doing wrong because you want to make sure you make any corrections right then and there. You want to make sure you are answering them correct 100% of the time. If you're still getting stuck on rounding, you can actually even ask like ChatGPT or Gemini to give you kind of like a rounding quiz, and just ask it to give you a rounding quiz using different units if you want, or even just different numbers, and then practice that. So that way you can get some feedback on it. But for the most part, as everything that we're looking at so far, and I'll give you some examples in a future review, a future workshop, we're pretty much going to be rounding to the nearest tenth for anything that like ends up with a bunch of decimal points. Okay. So just pay attention when there's a lot of decimal points. That's usually your clue that you should be rounding. If you get something that's like, let's say it's 34.999999999, that is a whole number 35. That was just like a calculator issue. So I'll address that if we ever run into it. But I think for right now, we won't have to worry about it. So as always, if you have questions, please send me an email. Next week, I'm going to be doing, I'll meet again on Thursday, but at around noon. So hopefully that time worked pretty good last week. And then I'll do this again at 4 o'clock in 2 weeks. And if I need to add any additional times, I will do so. Review if you can't be here live, just watch the replays. And I hope you have a great rest of your day.